I'm starting the recording now. All right. So yeah, so a little bit of just introduction for me, that who am I and etc. So today we're going to have some session, some discussion over introduction to electrodynamics, and I'm very grateful that the organizers basically, give me that opportunity to delve into the subject and give some, basically the undergrad level electrodynamics things to deliver to you people. So if you have any questions, obviously you're going to ask me, just interrupt me, unmute yourself and ask those questions, whatever you have. And my name is Mukesh Kumar. I am a professional physicist according to the South African standard, as well as I am a Y-rated scientist working in CERN with the ATLAS experiment and basically for the particle physics and all the stuff. So if you have to have any questions, you can always email me, which organizer believe that they had provided me this email ID, which is mukesh@uexed.com. And you might know this thing from the website itself, where you have a lot of things, to go through. So basically in this course, we have a goal to set up, and that goal is to reach up to the Maxwell's equations, where we unified basically the electromagnetism all together. So let me start with the laser pointer, which you can see here. So our goal is to reach up to these equations. And there are some plans which I basically made for you. But that could be modifiable according to the time and, the constraint which we come through to reach that goal. So basic thing which you can see from these equations, that we use some of the symbols. So, we need to understand that what this symbol means and how this mathematics is basically going to affect our calculations. And you can see the same equations has been written in a different form as well. So that means it is just like a unit conversion that we're going to talk about. And I will go into the detail of that while I will, move all together. But to this point, to reach this point, we need to first practice a little bit of things which should be like preliminary things. And, these equations will come as a Maxwell's equations later on. Maybe in the 12th or 13th lecture, I'm going to discuss this thing. All right. So let me move ahead. And these are some of the contents which I prepared. And for completeness, I would just say that I'm going to follow basically two books. One is by Griffith and one is by which basically I will try to avoid, but we'll try to have Jackson's book as well. Okay. So far I will talk about some units convention which we're going to follow. Maybe it will go for a one lecture set or one session, or maybe I can, if time allows, I will also discuss vector analysis today itself, at least with some of the parts where I can cover up to vector algebra. And these differential calculus, integral calculus, curvilinear, basically these are going to be in detail in your mathematical physics classes on Monday by Dr. Rohit. But what I'll do here, I will just give some formula and some of the notations which I'm going to use for particularly for the this electrodynamics part. Then after I will, so far my plan is that maybe a fourth session I will devote to understand electrostatics, potential electric fields associated with the numerical problems, etc. Then after I will spend magnetostatics and magnetic field in 4 lecture. Then I will talk about electrodynamics, where we end up with the Maxwell's equations and electromagnetic forces, induction, etc. In between, we will also evolve according to the need, and we will see, how things goes away. Okay, so this is just a content which I wanted to put in so that we can have the overall picture that what we're going to discuss within these sessions. Okay. So what is electrodynamics and how this is basically related with the general physics? That's a big question that we should have when we start any topic to study. Okay. So if somebody can speak, I mean, it would be better that what you understand by electrodynamics so far. Can anybody speak up and
I think, sir, electric and magnetic effects due to moving charges.
very nice. Anything else and how it is related with general physics? Any idea, anything?
What is the question, sir?
Yeah, so how it is related with general physics? If I say, if you talk about physics, it is not only electrodynamics, right? You have many other things. So how it is related with general physics?
I have so little idea, sir. I don't know.
Okay, that's good. So no, I mean, this is also, I mean, you have to pretend or that what you know, and that's the way we discuss basically this stuff. So that's why I make this slide so that we can have a basic idea that what general physics tells us and how electrodynamics is basically correlated with that. So I will try to answer some of the question here. And maybe if some discussion starts, then we will go into the details of that as well. So let's start with a picture where we have these 4 boxes, which we see here. So we have classical mechanics, which we know, where Newton's law, etc., works very well. Also, there is something called special relativity, which was formatted by Einstein, and what could be the reason we're going to just see after a moment. Also, there are something called quantum mechanics developed by Bohr, Heisenberg, Schrodinger, et al., etc. Okay, and there is something called this 4th block, which is quantum field theory, developed by Dirac, Pauli, Feynman, Schwinger, et al. So you may think that we classify our mechanics part into 4, but why and how? Okay, so this question can be very much correlated when we talk about 2 things. One is called size and one is called speed. So first, if you go down from here to here, so in classical mechanics, Newtonian's law basically failed at very high speed. Okay, and that's why we have to develop a theory where special relativity basically comes into picture. And then special relativity says different laws that the speed of light should be fixed, blah, blah, blah. And we're going to discuss these in detail in the electromagnetic aspects as well, that where basically your classical mechanics lie if I talk about electrodynamics, and why we basically need special relativity as well if you talk about electrodynamics. It is not only important for your basic understanding of general physics, but also it is going to helpful for your competitive examinations as well. Okay, another thing is size. So you can see the arrow is basically, if you see it is going backward, because if you talk about very small microscopic particles, you have no explanation using the classical mechanics. And then you have to talk about quantum mechanics, where size is very, very tiny and very, very small, which you can't see by naked eye. Okay. So these are 2 basic parameters. When you talk about any general physics, you can classify basically the mechanics part into these 4 parts. Now you may ask that why this block is, because if you see from this diagram, this block basically refers to a small size because it lie in this coordinate. And this also lie with a high speed. So once you have a high speed as well as a small size, there are theories which we need to actually explain for any phenomena at the microscopic level as well as with the high speed. So you can say it is quantum field theory is just a marriage of quantum mechanics and spatial relativity. Okay. So these are some of the things which one should at least have an idea when you start learning physics in general. And then one has to ask a very particular question about quantum, quantum nature, classical nature, how they correlated, why electrodynamics is too important. If I talk about some general physics like this, so we're going to have some overlook, and then we will deal with that in detail. Okay. And one most important thing is that if you have any question, please unmute yourself and you interrupt me. Okay. So next part is about the fundamental forces. So in mechanics also you know that there are something called fundamental. Is there any question? Somebody unmuted? Hello? If somebody wants to speak something.
I think it was a bit disturbance. I think
Okay, no problem. Okay, so next part is to understand the fundamental concept of the forces. Okay, and we know that there are four fundamental forces, and it is I have written as the order of fundamental forces, like if you go from up to down, forces, basically the interaction capability is going to be in the increasing order. So you have learned these things in a very basic year, maybe in your class 11th, that gravitational force is one of the fundamental force which basically take care of all the visible things which we see, like Earth gravitation, and also why Sun and Earth gravitational force are working with the Newtonian gravitational force. And there we also described why gravitational mass is very important there, etc. Okay. Another important force which we know is the electromagnetic force. And when you go below microscopic level, then you have to talk about something like alpha decay, beta decay, the radioactivity effects, etc. by weak force. And then a strong force is very important when we talk about the atomic structure, where protons and neutrons are basically interact with each other, as well as we know that protons are having the quarks and gluons, and they are also participate in a very kind of class of force which we call strong force. Okay, so these are some fundamental things which is very important before going into the a topic like electrodynamics to understand these things. Another important question is that, can we unify these forces all together and make a simple theory from where we can define all the fundamental things? Okay, so these are the big questions that basically physicists start dwell with, and always trying to do this very hard. Okay, so how this going to be happen? Okay, so let me see what, yeah. So one of the things which we basically see from aspects of general physics, and the very first unification basically comes, is that electricity, magnetism, and optics are unified within the electromagnetic force. Okay, and basically we're going to dwell with these topics in these sessions. All right, I'm not going to talk about weak force, strong force, or gravitational force. Rather, I will just talk about, some relation we can think of between the gravitation and the electromagnetic force. But so far the course content is concerned, we will talk about the unification of electricity, magnetism, and optics, because you might know that electricity exists. I mean, when people started talking about electricity, they think that electricity and magnetism are different things. And optics, obviously, this is different, okay? But having some experimental observations where one can see that if charged particle moves, it also creates magnetism, or if magnetic force, if something is having the magnetism capabilities or magnetism characteristics, it also produces electricity. Okay, so one can come with very much idea, and basically those are Maxwell's and Lorentz. They come with the idea that no, they can be unified, and electricity and magnetism is nothing, but it is just like a frame of reference you are talking about, but they are just a one phenomena. And that's why we talk about electromagnetic forces as a fundamental force altogether. And that's the first thing where basically physical theories are unified. Okay. And then after, obviously, optics comes into picture, where one can say that light is basically nothing but the electromagnetic object. Okay, it is just like an electromagnetic wave. So then optics is also unified together, and these three things basically comes and make the electromagnetic force, which we are basically going to deal in this particular electrodynamics course. Okay. So then after, just for a very brief, review, so far what we have, that we have electromagnetic force, weak force, and a strong force also combined, which we call the standard model of particle physics, where you have to use QED, which is quantum electrodynamics, plus electroweak theory. They are unified together with a corresponding group. And about these groups, etc., you're going to talk these things in the mathematical physics classes, where this group theory comes as an introduction. And these are very basic introduction, where one should talk about the U1 group, SU2 group, etc. And then after, this strong force, which is basically nowadays defined with QCD, which is called quantum chromodynamics, where color is one extra degree of freedom, or you can say the charge of that particular force is color charged. So that's why it's called quantum chromodynamics. And it is going to be explained so far with the strong force. So standard model basically unify all these three forces. And this group is basically called, SU3C, because this is color charged. Outer product of SU2L group, which is left-handed, basically. This is the chirality and all those things, which obviously this is very advanced level understanding. So, but for completeness, I have to give you an idea that so far, after the unification of these electricity, magnetism, and optics, there are something called standard model in particle physics, which basically unify these three, fundamental forces. However, gravitation is still in a question, because this is very feeble. And however, people are working through quantum gravity, where they quantized with the graviton, etc. And there are some theory called, grand unified theory or string theory, where people talk about and give the solutions from where one can understand that, yes, these fundamental forces might be unified, but it's not possible yet. Okay. Because to get some experimental filling, you have to have a very high energy colliders, which we don't have for the time being, apart from LHC. And LHC is beautifully defined all these three, unification through standard model. And most of the particles, or I can say all of the particle spectrum from the standard model has been discovered and verified very beautifully to the present collider, which we call Large Hadron Collider. But anyway, so these are some of the general physics which I wanted to discuss. But next comes to the part where we wanted to discuss electrodynamics and why we wanted to discuss electrodynamics. Okay. So basically, electrodynamics with a classical, explanation, it defined with a field formulation, which you learned in your class 12 probably in your academic sessions, that a charged particle is there, which basically, let's suppose you have one charged particle and another charged particle want to talk with that particular charge. Okay, then how they're going to talk? So people say that, okay, So the first charged particle is basically have their own field, and if within that field another charged particle comes, then they started talking about. Okay, so this is the classical explanation of the charged particle, and we have to go up to that. But in quantum physics, you will see that field is also quantized, and that quantized field is basically giving you another mediator. Like, for example, if you have electromagnetism, then according to the quantum field theory, you will say that charged particles are talking through photon. Okay, so and similarly, if you talk about weak forces, electroweak forces, then there is heavy charged particles like W plus minus, and also one neutral particle, which is Z boson. They are talking to each other as a mediator with the fundamental particles. Similarly, for a strong force, there is called gluon, which is basically participate to communicate between the quarks and that colored charged particles. So, but come to the point where we talk about the classical physics, basically. So you know that basically, what is happening, that you have two kind of charges. One is called positive, one is called negative, and they interact with each other as an attractive force if they are having the opposite charge. However, if you have same charges, then they're going to repel, whether it is positive, or negative. So these are some of the basic concepts which you have already learned in your previous classes. Okay, and we're going to do this mathematical formulation, etc., in some of the class. So electric charge comes with the three property that is very important to understand, that they come with the two parts like positive and negative. They are conserved and they are quantized. So quantized means what? Here I put a star mark here, which I'm going to explain just now. So basic unit of charge we defined as a positive charge as a charge of a proton, okay, and negative charge as a charge of an electron. Okay, so these are the things which we basically taking as a basic unit. So if you say basic unit, what that means, that for example in general life you measure something, if there is something called mass, then you have a very tiny mass, then you can say that, okay, this is milligram or something like that. So milligram is one of the unit from where you can just multiply the factors and you can go up to the a kilogram or mega kilogram or whatever you want. So similarly, if you have some quantity in a directional quantity, then you just say that we can provide a unit vector which could be the the unit of that direction. Okay, so similarly you have the quantized charge and the basic charge. We can say the positive charge comes from the proton and the negative charge basically comes from the electron in the unit of. Okay, but however, as I put here a star mark, important thing is that to understand about the quarks, which we know because it is already having the foolproof signatures from the collider. So quarks are basically fractional charges, and the quarks basically coming in either up or down. So if you have an up quark, then the charge will be plus 2/3 of electron charge, and if you have a down quark, it should come with the minus of 1/3. Also, the entire particle of up quark will come with the minus 2/3 of E. Similarly, the entire down quark will come with the plus 1/3 E, so that they can make up. And you may ask one question, then why not we use this as a basic unit? Okay, so does anybody have any answer for this? Any clue on that? Yeah,
I think in macroscopic level, every charge is integral multiple of this basic unit E.
Right. But why don't? But we say that that's the question actually. That for quarks we say that this is 2/3 of electron. So is that physical or unphysical? Obviously not.
This subatomic particles.
Yeah. So the point is that you can't observe quarks. it is it is abundant within the proton or neutron. Okay, so that's why that doesn't matter that if you have a basic unit like this, but you can measure electron charge very and there are many theories which obviously at this stage you don't need to understand, but these are some basic things from the general physics that one has to have the whole understanding of. So I hope, the question which we're going to ask about the general physics and how electrodynamics is important, we answered with this, a brief introduction. And I would stop for a minute. Maybe if you have any question, if anyone have any question, please ask on this. Or if everything is fine, then I can move.
Sir, in the screen, you have written that standard model QED, EW plus QCD.
Mhm.
In the screen, there is a standard model written above string theory, GUT.
Yeah. So
The SU3
what's the
is,
question there? Yeah.
what does that mean?
Okay.
SU3.
Yeah. So as I said, this standard model basically unify these three forces. Okay. So when you basically represent electromagnetic force using quantum field theory, you can represent it by a group. Okay. And that group is called U1 group. And there the quantized charge is Q, which is basically the charge of electron. Okay. So this basically called QED, quantum electrodynamics. But what we wanted to basically study here is the electrodynamics. But when we talk about the fundamental theory from the quantum field theory, then you can say this as QED, and this is the very first theory which basically comes with in a quantized form. Okay, which explains basically a charge mediation. That means, which I explained here, that if two charge wants to talk to each other, they will talk through photon. That means field is also quantized. You understand my point?
Yes.
If you talk about the classical physics, field talk with the field. Okay. But when you talk about quantum field theory, field itself quantized, and then the two charges basically, talk to each other via photon. Okay.
Yes.
Now comes about the weak force. So weak force has some range where you generally see radioactivity is happening with the alpha decay, beta decay, etc. Okay. So that weak force is also quantized according to the QFT. And the charge mediator, the mediator of those fields are W plus minus and Z boson. Okay. So now the question comes out that can we unify electromagnetic force with the weak force? Okay. And weak force, according to the standard model, is defined with the doublet. Okay. And this is called, so this is unitary case, you can say unitary group theory. Okay. And this is a spatial unitary group where you should have a doublet, and this should follow the chirality as well. That means the left-handed particles should have this spatial U2 group that should be in doublet. However, right-handed should go into the singlet part. Okay. So the question is that can we unify this? So once we unify QED with the electroweak force, which is this one, okay, so then it should be represented by a new charge, which is called hypercharge, which is called Y here. And Y is the combination of the quantized representation of SU2 group, which is basically the T3 of isospin, the third component of the isospin for this group. And then they unify the charge, and then this Y is basically the unification of these two forces, or you can say these two groups can represent these unification. Okay. So, but obviously the understanding will come when you go into the detail of quantum field theory at the master's level or so. But it would be nice to have some general ideas that how basically science, and especially general physics developed these theories. Okay. And similarly, we try to have a strong force and try to explain it via a QCD, which we call quantum chromodynamics. And this is represented by, again, a spatially unitary group, but this should have a triplet explanation. So basically this charge, this up quark, down quark comes into 3 flavors, 3 colors. Okay. However, gluons comes with the 8 colors. Okay. Because of this group representation, and that's why we call it a charge. So, and then when we try to unify these things, we call it as a standard model. All right. Is it clear now?
Clear, sir.
Okay, that's very great. Any other question?
No, sir.
Okay, great. So let's go ahead and let's try to see the next part. So this is the very basic understanding. Now you can feel the physics. You know, when you go through all the lecture set, all the sessions by having all the experts, then you will see that you can see basically that where you lie. If you talk about electrodynamics, if you talk about optics, if you talk about quantum mechanics, then why it is important and how this is going to affect your understanding with the general physics. Okay, very nice. So let's move ahead for this particular topic, where I wanted to first of all introduce, you know, the unit system which we talk about. And you might know this, that you generally use standard units in the international system. So how basically they are correlated with the Gaussian system and those equations which I give in the introductory slide itself. Okay. So first of all, we all know Coulomb's law, which we go into the detail also while we go through the session. And there we know that Coulomb law says that, okay, if you have a 2 charged particles called Q1 and Q2, they're going to interact with each other. But this force is basically proportional to the product of those charges and inversely proportional to the square of the distance between them. Okay, so that's the proportionality thing which we come from the Coulomb's law. And 1 over 4 pi epsilon 0 is basically, you know, there's things that this is come as a, you know, constant of proportionality. Okay, and these are some of the convention that one has to talk about, that why 4 pi, what do you mean by epsilon 0, etc. And we will go when we go particularly for this particular topic, we will go there and try to understand. And basically, you see, you might think that why I am explaining this very seriously. The reason is, if you basically write your just exams or some exams where you have to be interviewed, then these are very basic questions where interviewer can ask these, you know, small questions, which basically, you know, we miss when we basically read, you know, at the time of our undergrad, we generally miss this point. But you need to be very, very careful when we talk about these symbols and, you know, why this 4 pi comes, what do you mean by epsilon 0, why not we can write like simple epsilon. Okay, why we should say epsilon 0. So these are some important concepts which we're going to discuss. So, and that's why I wanted to just flash out the whole idea of my sessions, where I'm going to discuss and describe everything in a very, very detailed manner. Okay, so this is the standard unit. And if I talk about the Gaussian unit, so in Gaussian units, basically what happens that we, you know, annihilate this constant within the charge. Okay, and then the charge is defined in the Gaussian unit, and there, you know, you can just write this force as Q1 Q2 divided by r squared, where r is the distance between, you know, these 2 charged particles. And you might know that this r cap is basically the direction, because you know that force is the vectorial quantity, and that's why direction is going to be very important. Okay, so even the moment you see that there is nothing written here like this or like this, so you can't say that this is wrong, this is right. The moment you see this, you will say, oh, this is in the Gaussian unit and this is in the SI unit. Okay, so these are very basic things that one has to understand once we start learning stuff, you know, from the basic ingredients. Okay, so what that means that if I wanted to convert from one unit to another unit, from SI to Gaussian units, then what we have to do, we have to just simply replace this epsilon 0 as 1 over 4 pi. So the moment you replace this epsilon 0 by 1 over 4 pi, you will see that you get this Gaussian unit. Okay. So let's try to have some understanding with some other expression. So let's suppose you have a electric energy. Because of the electric field, you have some energy, which you might know from your 12th class, that this is called energy of electric field. Okay. So let's suppose this is the SI unit. Then can somebody tell me that in Gaussian unit, how we're going to write it? Just work out on your pen and paper. I'll wait.
1 by 8 pi
1 by
8 pi integration square d tau.
Obviously I didn't understand, but anyway, so if you have this answer, then you are correct. So what you did, I mean, you just replace epsilon 0 by 1 over 4 pi, and then you get 1 over 8 pi, and this is integral of e square d tau, and this is the Gaussian unit. Okay, so this kind of questions can be, I mean, you can see in multiple choices of competitive examinations. So you have to be very careful, and you should know this by practice. Okay. Similarly, we can take, for example, Biot-Savart law, where we talk about the magnetic field because of the charge current. Then in SI unit, you generally know that you write this by mu naught divided by 4 pi, and then there is a current I, an integral of dl cross r divided by r square. Okay, so can anybody again work out this and tell me that how you're going to write in the Gaussian?
I by 16 pi square integration dl into r cap divided by r square.
Okay, that's good. So there you what formula you use for to eliminate this mu naught?
U not equal to 4 pi, I think. The 4 pi cancel out.
So there is a relation between mu naught, epsilon naught, and speed of light. Okay.
Yeah.
So by using that, you can write this as I over c integral dl cross r divided by r square. Okay.
So is the equation c equal to root over mu naught epsilon naught?
Yes, it says c is equal to 1 over root mu 0 epsilon 0. Okay.
Yes, yeah.
So yeah, see, these are very basic things, but these are the important thing for your competitive examinations, whether you write NET exam, whether you write JAM, whether you write, obviously I'm out of track of that, so I can't say very confidently, but yes, these are very important thing for question setters to look into. Okay, so next maybe we can talk about the Lorentz force. So can anybody again work on that? So if you have a Lorentz force where you have a charge times electric field plus V cross B, then how are we going to change it into the Gaussian unit? If somebody is in, can you look at the chat as well if somebody is replying there? Somehow I can't see. Okay, so let me just go ahead and you might work on that, and then you will come back to me if you have any question later on. So this force should be in the Gaussian unit, should be written as V over C cross P. Just the changes here. We generally break the symmetry of giving a few things like that. So this needs to be basically work out. So that's why I just gave you the answer. Please work out in the workout, and maybe in the next session you can give me the ideas. Okay. So somehow I can't click on chat.
I have one question.
Yeah, sure.
What is the significance of Gaussian units? Why you use Gaussian units?
Yes, that's a big, that's the question. Basically, once you talk about, as I said before, that few things are very common in a different unit representation. Okay, and I'm going to give you the list of that. And it is something like some of the physics can be explained better in Gaussian system rather than SI system. Okay, so sometime you wanted to just write this like your Coulomb force is Q1 over Q1 Q2 divided by R square and just go ahead without using that. Okay, and you're going to see this when we talk about the displacement current, etc. And then Gaussian units are very freely to use. They are very rather I would say that's very compatible to use. Okay, so there are no such significance. That's not huge significance, but sometimes you have to talk like this. Okay.
Okay, sir.
Good. Is there anything in the chat? I mean, can you read it for me? Because I can't click on that somehow. Can somebody read it for me?
There is no such, sir.
Okay, anyway, but I see there is something red, but anyway, fine. So let me go ahead and other way around, maybe you can see something like this, that you have if you have electromagnetic field and you write the energy of that field like 1 over 8 pi integral E square plus P square d tau in a Gaussian unit, then how you're going to change it in the SI unit. Okay, so these type of questions can also be very relevant when we talk about that. Okay, so I'm just giving you the answer. So this is going to be epsilon 0 E square plus 1 over mu 0 B square d tau. Please note these things and try to solve by yourself as a homework. All right. Very good. So let me go quickly to the next part of the things which I just mentioned, that these are some of the conversion factors, which is basically important. So from SI to Gaussian, basically in Gaussian, the length is denoted as centimeter. In SI unit, you have a meter, and there is a factor of 10 over 2. Similarly, for mass, you have a kilogram, and in Gaussian unit, you have a gram, etc. Okay, so you can find these things in the standard book, and you might need to remember a few of the things by yourself. Okay. So if people feel comfortable, I can go ahead because I think I already passed 45 minutes, right?
Proceed, sir.
Okay, that's good. So okay, so these are some of the basic things, and this is very important that we're gonna the conventions and notations which I'm gonna to talk about in the whole my session is something like this. Okay, and I said before that I will follow all things from Griffith's book, or similarly, I mean, in the J.D. Jackson, these kind of notations has been used. So variety of notations are there available in different books, but I'm going to stick with something like this. So when we write Cartesian unit vectors, I will write like x small x with a cap. Similarly, in the y direction, you have a unit vector y cap, and in the z direction, you have z vector. So we all know that we live in 4-dimensional world. So I mean, you have a 3 axes, 3 space axes, and you have a time as well. So these basically combine together with a different unit system. So sometimes we're going to use Cartesian unit system. Sometimes you're going to use a spherical coordinate system, for which I think in Dr. Rohit's class, you're going to basically having those ideas that how one can go from Cartesian to spherical to cylindrical coordinate units. And those are very important, basically, when you talk about, electrodynamics and things like that. Also, in the cylindrical coordinates, as I said, we're going to represent z-axis like this, like small z, and coordinates are designated by small s, and you will see when we go for I just gave these things for the completeness, so that you should not be confused when we talk about this kind of things. So these are, so we're don't going to use this r as a distance origin, because in the radial coordinate we generally use r, and also in the spherical polar coordinate system. And script small r like this, like a curly kind of r, which we generally denote the vector from a source point r prime to the field point r, like this. So if you have a source point which basically create your some charge, let's suppose some charge is staying here, so this is the source point. And if I wanted to represent the field point here, then we're going to have, for example, with respect to this xyz coordinate system, we can say that this is a r vector for the position vector for this field point, and r prime is the position vector for the source point, and the distance between source point and field point is denoted as r, which is basically nothing, but you know that this is r minus r prime. Okay, so these are some of the notations which I think is important to go ahead. Okay, so there should not be a confusion when we go into the details of that. Okay, so maybe I will go for a very brief overview of vector analysis, because this is also important for me, to having this all knowledge all together. Okay, but in detail, as I'm saying again and again, these are the parts of the mathematical physics which Dr. Rohit is going to give you more and more, ideas. But for notation purpose, I would like to, give these things. So we know that the addition of two vectors can follow this law, where you have a vector A plus vector B, and it should be equal to B plus A, means it is commutative. Similarly, if you have a three vectors, then you can use this law where you have a plus B added with C, and also you can have either A should be added with B plus C. Okay, so these are some of the things which basically this follows. Also, when we say the subtraction of two vectors, we can say in general that this is not a subtraction but also an addition with the vector B in the negative direction. Okay, so this is very important to understand in a vectorial notations. Another thing we know about the multiplication by a scalar, which we're going to follow. So if a scalar is there and you multiply with a vector quantity, you can have a distributive law simply that A could be multiplied with the A vector plus A could also multiply with the B vector and can be added together. Okay. Similarly, dot product. So I'm going this very fast because you people know these things. I just wanted to be, like a summary of some of the vector analysis part today. And tomorrow, in the next session also, I will continue and stop vector analysis and will start electrodynamics, because I meant to, have this in two sessions. So in dot product, you have a dot P, which could be represented as AV cos theta, which we know very, because A and B basically making angle theta, and then you can represent the dot product as the scalar product as a AV cos theta. This is not a vector product. If you talk about vector product, it's going to be A cross B, which I'm going to discuss in a while. So also, this law basically give you A dot B equal to P dot A. Also, you have, for example, two vectors added, and having the dot product with a third vector, then you can similarly write like A dot B plus A dot C. Okay. Now, with this, if two vectors are perpendicular, then how the dot product is going to behave? Can somebody tell me? Let's suppose you have a two vector A and B, but they are perpendicular, and you take the dot product. So what is going to happen?
0.
Why?
Is equal to, because cos 90 degrees equal to 0.
Is equal to, so 0. So this is A dot B, which is very known. Similarly, if you have a parallel vector, then what is going to happen?
Just the product of.
Right. So just a product of the magnitude of these two vectors, right? So if I say the magnitude of vector A is A and magnitude of vector B is B, then it is just going to give us a scalar product. And that is why you can see here that if I use dot product or scalar product, so as you know that the scalars have magnitude only. Okay. So this you can see from the product itself that this is scalar product, and that's why sometimes dot products can also be said like a scalar product. Okay, so these are very integral part of understanding of the points which we are discussing here. Now briefly go through the cross product of two vectors. So you know that cross product of two vectors can because these are the vectorial thing, unless you have a like in the dot product. So cross product can also be said like a vector product, okay, because it has a direction. So we can represent it as a n cap, and we can just figure it out something like this by right-handed rule. If you have a, let's suppose vector A is indicated by this, generally we call it a right thumb rule. Okay, so if your forefinger basically represents this A and your middle finger represents B, then if then your thumb is basically determine your A cross B. That's the vector product of that. So A and B have been making the angle theta, and within this plane, this is basically this is a plane, and this is perpendicular to that. Okay, so this is C vector, which is called a dot product of A and B, and this is represented as the sine theta with the product of magnitude of A and B, and n cap is the unit vector in the direction of A cross B. Similarly, this could follow some laws, which is A cross B plus C. So A cross B plus A cross C. It is similar like what we did for the dot product, but here, you see these are the scalar products with two vectors. Here we have a cross product of these two vectors to be summed up. Okay, and these are some law which one should know, that if you have a B cross A, then it should be negative of A cross B, because this is a vectorial quantity. Unless we see here that in the scalar product you have A dot B equal to B dot A, but since this is a vectorial product, so once you change the order, like A cross B change to B cross A, then there should be a negative sign for A cross B. Okay, that means if you see in this figure, it is going to denote it in the negative direction. Okay, so that means like this. So you have a two vector A, B, A cross B is going to in this direction with n cap, but B cross A is basically minus of A cross B in the negative direction. Okay, so these are some of the important things which I wanted to tell you. And then the important thing is magnitude of A cross B, how this is physically meaning to us. And this is again important for your competitive exam. Sometimes this type of questions basically I had seen basically maybe 15 years back, but such kind of questions are very important to understand, that if you take the magnitude of, because there should be a physical reason for these cross product. People can ask, what is the physical reason? Why you are taking this cross product? I mean, is there any physics behind that? So you can see that this basically gives you the area of the parallelogram made by the vectors A and B, and which you can see from here. So if you have A cross B, like which is making L theta, then this A cross B give you the area of the parallelogram. So one could ask a simple question, that can you determine an area of a parallelogram given the vector A and B? What do you have to do? You have to just find the magnitude of A cross B, and that is it. Your answer is there. Okay. So I hope there should not be a question on that. If there is, then please unmute yourself and ask any question if you have. So I think all good.
Excuse me, sir.
Yeah.
Can you please show the third slide?
I mean, before this, what I did.
Yes, sir.
Okay. So let me see. It will take a little bit of time. You could have asked that question at that time, actually. Anyway, yeah. This one or before that?
The previous one.
Okay. This one?
No, sir. Third
This
slide.
one.
Yes,
Yeah.
yes, sir. Thank you, sir.
So just take the screenshot or whatever you want, and I need that you people should answer these questions by yourself, okay? That's why I give you the answers along with the questions, and these are going to be very important. As I said, whether you qualify your test, written test, in your interview, people can ask these questions very, very easily, you know? So you have to be very sure about that. When you're done, please let me know, then I will move forward, okay? In either way, I'm going to put this recording in the YouTube channel for this UEXED. So, I mean, you can also revise from there also. All right. Are you done?
What is the name of the
Yeah.
channel?
Yeah, please go ahead. I'm listening.
What is this channel name? YouTube channel name?
Sorry, what? YouTube channel name? I think I'm not basically very friendly on that, but you should just go into the website and click on YouTube. Then maybe you're going to see this. If I'm allowed, let me just see if I go back. I had given you something on the very first slide. Yeah, here you see. If you go in this website, you go just the downmost part, and you will see that there are some social media links. Okay, so once you click YouTube, you're going to see that. Okay, I believe. Okay.
Okay.
Okay, very good. So let me go through the slides again. So are you done on slide 3? Sorry, I can't see your name, so I can't speak your name. But are you done with the third slide?
Yes, sir. Yes, sir.
Okay, very good, very good. So I'm going to stop in a few minutes by having this introductory session of vector analysis, and in the next session I will try to again go for the differential calculus, etc. But before that, I would like to have, I will give you 1 minute. Can you calculate the dot product of C with itself? And the diagram is given here. So if there is any confusion with question, you can ask, but I hope this is very straightforward to understand. What you have to do, you have to just calculate the dot product of C.
Sir, should the value be in terms of A and B?
Exactly, yes. Okay, so tell me, what is C in terms of A and B?
A minus B.
Okay, good. So then dot product will be then?
A square minus B square, I think, sir.
That is it. Anybody else?
So dot product of C is a C square. C square equal to A square plus B square minus twice AB cos theta.
Are you sure?
Yes.
Okay, so let's do it one by one. Okay, so we know that C is A minus B because we know that vector addition formula is going to work here. So B plus C is going to give you A. That means C is equal to A minus B. Okay, now we wanted to take the dot product. So C dot C is nothing but A minus B dot A minus B. Okay, now when we open this, what are we going to do? Like A dot A, then there will be a minus sign. So A dot B, then there will be again a minus sign, B dot A, and then there will be minus into minus plus sign, and we will going to have B dot B. Okay. Now we're going to use the formula for the dot product, which we just learned. So we know that the dot product is basically the cosine angle. Okay. So when we have A dot A, that means A and A are parallel to each other. That means theta is equal to 0 and cos 0 is 1. So this is going to give me simple A square. Similarly, B dot B is going to give us B square. But we have here A dot B, or we already saw this that A dot B is going to have magnitude of A times magnitude of B times the cosine theta, because theta is given here between A and B. So similarly, B dot A is going to give us dot product is going to give us the scalar product of A, B cos theta, and then we can write this. And this is very famous known formula which you might have used, which is called law of cosine. Okay. So is it clear to everyone?
Yes, clear, sir.
Very nice. Good. Similarly, you can write for this formula for A square, B square. So you have a triangle, the theta, then, corresponding to that theta, you can always find this sort of, law of cosine. So you can work out for all these, three stuff. Let's suppose this is phi, this is something called kappa, then you can find, this law of cosine for B square as well as for the A square. Okay. Now, this is just a homework that you should work by your own, because this is going to be like a very freely going to be used. That is why I am revising this all part. Okay, so please be careful and don't think that I'm just giving you some preliminary things which you already learned in your 11th and 12th class. Rather, these are going to be very freely used. And similarly, yeah, so law of sine is going to have something like, if you have a triangle like this, then you have a sine A by A equal to sine B by B equal to sine C by C, where this angle is A, this angle is C, this angle is B, etc., and the sides are defined accordingly. Okay, so just look over these things. And a few things which I just wanted to mention before I close the session, which is called vector algebra. So simple algebra is something like this. So let's suppose you have a three-dimensional vector, okay, and we're going to define it as a right-handed system. Okay, sometimes you also see that there are some convention which people use like a left-handed system, but I'm going to use it right-handed system like this. Okay, so you have a x vector, x unit vector in the direction of x-axis. Similarly, you have a y unit vector in the direction of y, and z unit vector in the direction of z. Okay, so by having this, you can define any vector A like this. Okay, so let's suppose you have any vector A. So what that means, it is just in space from the origin. So this should be a combination of the component. Okay, so in x-axis, let's suppose the magnitude of this vector is ax. So we can define vector A in x direction as unit vector x times the magnitude of that particular vector. Okay, similarly for y, we can define, so you can just parallelly write this because these are free vectors. You can parallelly always transport, and you can write something like ay times y cap, and then you go up and you say that this is a azz. Okay, so you can represent this as simply like this. So vector A is nothing but sum of all the components all together. So this is axx plus ay plus azz, where x cap, y cap, z cap unit vector in that particular direction, and ax, ay, az are the magnitude of the vector in x direction, y direction, and z direction respectively. Okay, so this is the full way of defining a vector in a three-dimensional space in the And this is particularly for the Cartesian coordinate system in a component form. Okay, we're going to use it very frequently. Now, let's suppose similarly we have a B vector. Okay, and suppose that B vector has a bx x plus by y plus bz z. Then the sum will be simply that you have to add all the x component, y component, and z component together with the unit vector, something like this. Okay, so you have vector A, you have added with vector B. So what we can do, you can add the magnitude of these two vectors, similarly this, and you can write something like this. So this could be some vector C, let's suppose. So Cx will be Ax plus Bx in the x direction, Cy could be Ay plus By in the y direction, and Az plus Bz will be Cz in the z direction. Okay, so these are some of the things which we going to use very frequently. So please keep these things in mind. Also, the dot product of the unit vectors. So as we just work out that dot product is nothing but the magnitude of both the vectors times the cosine angle. So if you have a x cap dot x cap means you have this vector, this unit vector. A unit vector means the magnitude is unity. So x cap dot x cap is going to equal to 1. Similarly, y cap y, similarly z cap z. Okay. However, if you have a dot product of x with y or y with z or z with x, then they should be equal to 0. Okay, so these are some of the important things that I wanted to just explain to you. Similarly, you can find then A dot P very simply, because now you know that how unit vector basically work. Okay, so can somebody quickly say what should be A dot P? It's very simple, right? Yeah.
Ax bx plus ay by plus az bz.
Very nice. Yeah, because you use simply this dot product of the and dot product of the same components and dot product of the perpendicular unit vectors. So by using that, you can simply write this as this one, and then you can write this as ax bx plus ay by plus az bz. If anybody have any question, as I said, you can just speak up. Okay, just interrupt me. Similarly, for cross product, we know that x cross x is equal to y cross y equal to z cross z equal to 0, because this is sine angle and sine 0 is equal to 0, which we saw before. So by using that, these cross products are going to be 0. However, when you talk about, as you see in the dot product, this is other way around. Okay, so here you can see that x cross y is basically minus y cross x equal to z cap. Similarly, like this. So to follow the simple convention, I would just to remember this, what you can do, you can have a clockwise direction, something like this. Okay, let's say this is clockwise direction and denoted by the unit vectors. So this is x cap, this is y cap, and this is z cap. Okay, so if you do the cross product, just go like a clockwise direction. Okay, as the clock moves, basically clock handles move. So if you go x cross y, you're going to get z, simply like this. So x cross y, you're going to get z. However, if you just change the direction and go something like y cross z, then this should be minus z, and that's why we took like this as a minus direction. Okay, similarly, if you go from y to z, you're going to get x, but if you go z to y, you're going to get minus x. So just use this clockwise direction thumb rule, and you are through with that. Okay, so maybe this could be a last slide for me for today's session, and I will end up with one of the problem again. So can anybody tell me what could be A cross B if you have such a configuration? Anyway, let me explain it because it will take a little bit of time to, and I already, took your time a lot. So to write this, what you can do, you have to have this vector A cross the V vector in the component form. Okay, and now we're going to use the formula which we just discussed. So if you go with this, x cross x is going to be 0, y cross y going to be 0, z cross z going to be 0. However, you have the xy to be like z cap. Similarly, xz is going to be minus y, etc. By using that, you can write this in this form. Okay, and in a very simple form, you can use the determinant where you can have the cross product like this. So x, y, z, and then you write, because this vector comes first. So you have to write the component of this vector first, x, a, y, a, z. Be careful. And then the second part comes like b, then you have to write bx, by, bz. You're going to see that this is in the determinant form like this one. Okay. So let me end with this one of the question which I prepared for you, and just in 5 minutes, maybe we can end up the session. But let's try to find angle theta given in this. So for this, I just gave some hint that how we're going to write this. But you see, I'm going to explain it, but please try by yourself. Okay, first draw this diagram and try to find this angle theta in this plane. Okay, so how are we going to do that? First of all, we wanted to write what is vector A and what is vector B. So you can see that this is the plane. This vector is making a plane between x and z. Okay, and this has a unit coordinate. So you have 1, 0, 0, and this is 0, 0, 1. So you can write a vector A as 1x plus 0y because there is no y component in this plane, and plus 1z. Similarly for B, B is in this plane, okay, which is zy plane. So you can write this as a 0x plus y, 1y plus 1z. And then you can simply, what you can do to find the theta? Does anybody have any clue? What you can do? Or somebody have answer already? Then you can share with me.
Dot product should be done between A and B.
Yeah, good. And what is that then? What could be the theta then?
Cos theta equal to A dot B divided by magnitude of A and magnitude of
A
B.
and B, and thus you're going to get the answer something like this. Okay. So by using all the formulas, the magnitude, etc. So the magnitude can be defined as root over x square plus ay square plus az square. So by using this, you're going to get root 2. Similarly for B, you're going to get root 2, and this is the angle cos theta, and then cos theta can be determined because A dot B is 1, so this could be 1 over 2, and as you know, from 1 over 2, theta is going to be 60 degrees. Okay. So with this, I will end my session today, and for next session, I will again take some of the differential calculus, which is very, very important. So I will just put the formula there so that, for further sessions, you should not be confused that why I use those differential distributions, etc. In the lecture set. Okay, so to end this session, I would like to have any question you have in your mind or any suggestions you wanted to, give for further sessions.
Sir, is there any book recommendation from you about?
Yes, I told you, Griffith and J.D. Jackson. These two books are going to be the basic book. Yes.
What is the name of the book
Okay.
written by J.D. Jackson?
These are very famous book. You just Google it, you will find. But for Griffith, the name is Introduction to Electrodynamics, and J.D. Jackson is also something like also electrodynamics or something like that. Okay.
Okay. Thank you.
Yeah, because these two books are the base book, for to not only get your undergrad degrees, but also in masters, they are going to be useful. Apart from if you go into the research area, I mean, completely going to be like integral part of your knowledge, and also for the competitive exams. These are the minor point which I just explained are very, very, very important. Okay. Any more suggestions, query? for anyone? Which I should take care in the next session as well, if you have anything to discuss.
So I think the basics should be cleared very fast because we have this knowledge from higher secondary.
Yes, yes. So that's why I just keep this 2 lectures. One lecture I just give you the overall general physics, okay,
Yeah.
and how it is correlated with the electrodynamics. What are the notations I'm going to use? But the next session will be completely new things for you, where I will discuss the differential calculus
Okay.
for the vector, okay,
Mhm. Okay.
and that will end. And then from the third session, I will start the electric part, electric field, etc. Okay, with problem set. Is it fine? Is the plan
Okay.
sounds good? Yeah.
Okay.
Yeah, because you should know that how this. If you go back to my introductory slide, you might see that. Let me go back. So in the introductory slide, I denoted something like delta dot T, delta cross P, etc. Right? So did you have any idea what is this delta means?
It is del operator.
Yeah. So what is del operator means?
It is a vector operator, partial differential operator. I think the del x.
Yes. Yes. Yeah. So we are going to deal this in a very detailed manner. Okay. So that's why I wanted to have something like introductory, so that everything should be revised in 2 lectures, and then we're going to use it in a full way. All right.
Okay, sir.
Very good. So thanks for joining and your suggestions. But I can take 1 or 2 questions, more questions if somebody have. If not, then thanks again and for joining. And let's see how things goes. Okay.
Okay, sir.
Thank
Thank
you.
Thank
See
you.
you again. Okay.
Okay, sir.
Very good. Bye. Bye. ¿Cuánto? Oh.